Hello everyone, and welcome to your video on slopes. So let me draw a graph for you here, and this is your X and your Y axis. And when we're talking about slope, we are talking about the tiltiness factor. Tiltiness factor. Now, no real mathematician calls it the tiltiness factor. Well, I should take that back. I'm a real mathematician and you're a real mathematician, and we call it the tiltiness factor. No one who has a PhD in math probably calls it the tiltiness factor, but who cares what they think? Okay, so we're looking at the tiltiness factor. So I'm going to draw you a couple of lines here, hopefully all in very different colors. So here's a line that is straight. Pretend like that's straight. There's a line that is straight. And so this line has no tiltiness. This is just walking on a nice flat sidewalk, no problems at all. Here we have a line with a little tiltiness. It's a little tilty. And then here we have a line with a lot of tiltiness. Okay, these are all lines with different slopes. So we would say here that the slope of this line is 0. That means it has no tiltiness whatsoever. A line which is a little tilty might have a slope of, let's say, 1/2. And a slope with a lot of tiltiness might have a tiltiness factor of 4. So you can see that the numbers get bigger the tiltier your line is. Now, this also works in the opposite direction, and I will show this to you here. Here's another graph. And so once again, we have our no tiltiness line. But we can also draw a line with a little tilt, or we could draw a line with lots of tilt. Your slopes here might be something like this. This would be an M of 0. This would be an M maybe of -1.3. And this would be an M of maybe -5. Okay? So you can have positive slopes or you can have negative slopes. So how are you going to remember whether we're dealing with a positive slope or a negative slope? Well, I want you to imagine that you are walking along, and you're walking in the same way that we read. So you're going to start on this side of the page and you're going to go this direction. So at some point, the path that you're on might start to go up or down. If it goes up, it's going to take more work for you. And so then this is going to be, your M is going to be positive, because you're going uphill. Here, your M is going to be negative because you're going downhill. So that's a way that I remember in my head, is I imagine that I'm walking along here, and oh, now I have to work really hard to get up there, right? So that must be a very positive slope. And then this one is, woo, I hardly have to do a darn thing. I just fall right down there. Yeah, that is a very negative slope. All right, so that's kind of what slope is all about. I want to talk for a second about how we calculate slope. So let me draw you another picture. Again, these are my axes. And we are going to say that we have a line that looks like this. Okay? It's just a line on the graph. You're going to pretend that it's straight. So when we're measuring slope, we get to pick any 2 points on this line. Any 2 points. So we could pick this point and this point, and we would draw ourselves a right triangle, and then we would measure the rise, which we're going to say is 2 in this situation, and the run, which we're going to say is 1 in this situation. So we have our slope equals rise over run. Okay? Rise over run. Now, remember I said that this works for any 2 dots. So if you picked these 2 points right here and you made a little teeny weeny triangle right there, and this was a rise of 0.5 and this is a run of 0.25, that would also work. However, usually we don't make these little teeny weeny things here, because then we have to squint and we have to go buy new glasses because we've ruined our eyes by doing math, which is not a good thing. If you're going to ruin your eyes, you should ruin them on video games. That's what I say. All right, so then the other thing that we can do is we could draw a huge thing. And so then maybe we would get that this is a 20 and this is a 10. Right? You would measure from this negative here to 0, and then also the positive numbers, but the whole distance is going to be a 10. Notice that no matter which pair of these numbers you're using, if you're using 20 over 10, or if you're using 2 over 1 for the pink triangle, or if you're using 0.5 over 0.25 for that number, it always works out the same. Your slope is always 2 for this particular line, right? So my point is that it doesn't matter which 2 points that you pick on the line, your slope is going to be consistent. That is true until we start dealing with calculus, and calculus is all about how you measure the slope of a curved line. Like, what is the slope right there? But okay, but I digress. That is that's, you know, in your mathematical future. So let's talk for a second about this formula. M equals rise over run. I'm just going to write it down here again. M equals rise over run. I want to write it again because it is written differently at different times, you know, depending on who wrote the math book that you're reading or who's writing the problem up on the board. Some people just always write it like this, that it's rise over run. Some people, and this is the way I learned it, so this is the way I often do it, just because I've been doing it this way for decades now. The change in rise over the change in run. So if this is here, I would measure the distance between this dot and this dot, which is the change in what my rise is. Maybe it started at 10 and it ended at 12. So the change is a 2. Change in rise over change in run. Remember that little triangle there is a delta sign, and that means change. Okay? Some people do this as the change in y over the change in x. You're looking at how your y value changes, and you're putting it over how your x value changes. All of these mean the same thing. Okay? So don't be frightened if you encounter a different thing. It's always rise over run. Slope never changes. Rise over run, rise over run, rise over run. Okay, that is your brief introduction to slope.